Hi guys, and welcome to Module 6. In Module 6 we talk about ratios and rates. On this slide we talk about the three different ways that we can name a ratio. A ratio can be named in the word form. In this case we have 5 dogs to 3 cats, and therefore word form would be 5 to 3. A ratio can also be written in colon form, where you put a colon between the two items that are being compared. And last but not least, you can write a ratio in the fraction form. In this slide, we learn about equivalent ratios. And equivalent comes from the word equal, which means the same. So equivalent ratios means that we end up with the same comparison by either multiplying or dividing both the top and bottom terms by the same number. So if, for example, in this first one where we have 2 to 7 and we multiply both of those terms by 2, we would end up with an equivalent ratio of 4 to 14. This is said to be a multiplicative relationship because we are multiplying in order to come up with the equivalent ratio. Now, there is a note here that tells us that a ratio with terms that have no common factors is said to be in simplest form. So, for example, 2 to 7 would be in simplest form because there is not a number that we can divide both 2 and 7 by. They do not have a common factor because they already are in simplest form. However, the next one, the ratio 8 to 24, however, does have a common factor of 4, and so we can come up with an equivalent ratio of 2 to 6. Now let's practice what we know about ratios and apply it. In this slide, it tells us that we make 5 cups of punch, and those 5 cups are comprised of 3 cups of cranberry juice to 2 cups of apple juice. And then the question asks us how much cranberry juice and how much apple juice would you need to make 4 times the original recipe? Well, my first step is to write the ratio. And the ratio of 3 cups of cranberry to 2 cups of apple juice is the first thing that I'm going to do. Now, the next thing that I'm asked is how much cranberry and how much apple juice am I going to need in order to make 4 times the original recipe? That means that I'm going to have to multiply both terms by 4, the cranberry and the apple juice, and that will tell us how much apple juice and how much cranberry juice I would need to make 4 times the original recipe. Well, I started with 3 times 4 times the amount would be 12 cups of cranberry juice to 2 cups of apple juice times 4 times the amount would be 8 cups of apple juice. And so an equivalent ratio for 3 to 2 would be 12 to 8. We also talked about completing a table in order to determine multiplicative relationships in ratios. And in this example, they tell us that in each bouquet of flowers, there are 4 roses and 6 white carnations. So in this case, that would represent bouquet 1. They tell us to complete the table to find how many roses and how many carnations there are in 4 bouquets of flowers. So in order to complete this table, I'm going to go ahead and represent the different bouquets. This is going to be bouquet 2, 3, and 4. And even though they give me up to 5 bouquets, and I can complete up until 5, I'm only asked about 4 bouquets. So I'm going to stop there. Now, if there are 4 roses to 6 carnations in one bouquet, that means that in the second bouquet, I'm going to have to multiply by 2 in order to see how many total roses and how many total carnations I have in bouquet 2. So in this case, I would have 8 roses to 12 carnations. But now we have to be careful when we get to bouquet 3 because we're still going to use the original 4 to 6. And so in that third bouquet, I want to make sure that I go back to my original term and my original ratio, which is 4 to 6. That means that if I have 3 bouquets, I would now be multiplying by 3 in order to get how many roses and how many carnations there are in bouquet 3. So 4 times 3 would be 12 roses, and 6 times 3 would be 18 carnations. Again, going on to bouquet 4, I want to make sure that I stick with my original ratio, which is 4 roses to 6 carnations. And so if I'm going to 4 bouquets, that means that I'm going to multiply both the roses and the carnations by 4. And so I will have 16 roses and 24 carnations in 4 bouquets. We also talked about the difference between a rate and a ratio. A ratio was just the numbers, whereas a rate specifies the quantities that we are comparing using different units. So in this example, this is a rate because we are comparing $27 to 3 pizzas and not just a ratio of 27 to 3. We talked about finding a unit rate. We talked about unit coming from the word uno, which means 1. And a unit rate compares a quantity to 1 unit of the other quantity. So for example, based on our previous slide, the rate originally was $27 to 3 pizzas. Well, if we wanted to find the unit uno, 1, how much is each pizza, we would divide by 3 in order to determine that the unit rate would be $9 for 1 pizza. This was one of my favorite questions that we've done in class thus far. And the reason I like it so much is because we really can apply this to our real world. And I spoke to you guys about how your parents do this all the time when they go to the supermarket. If they came across these 2 different brands and they see that they can pay $3.84 for brand A, which is going to give them 16 ounces, versus paying $4.50 for brand B, and they will get 25 ounces, they want to determine which is the better buy. Now, we talked about how you can't just go by the price and say, well, the $3.84 is clearly the better buy because it's cheaper. Well, that's not the case because, yeah, it's cheaper, but we're getting less ounces. So our job here would be to use the unit rates in order to compare the prices. So we really want to know how much are we paying per ounce, and that will tell us which is the better buy. In this first example, let's do the Juicy Juice first. We're going to pay a total of $3.84, and we're going to divide that by 16 ounces, and that will help us determine how much we're paying per ounce. We're going to go ahead and bring up this decimal point. That is the rule to dividing a decimal by a whole number. 16 does not go into 3, but it does go into 38 2 times, and 16 times 2 will get us 32. We have 6, and then we're going to bring down the 4, and 16 goes into 64 4 times. And so what we see here is that we are paying 24 cents per ounce for the Juicy Juice. Okay, let's go on then to the Simply Orange, in which we're paying $4.50 total. And we're going to divide that by the total ounces, which are 25. Let's divide that and see how much we're going to pay per ounce. So we bring up our decimal point. 25 does not go into 4, but it does go into 45 one time. We take 25 from 45 and we get 20, and we bring down the 0. Well, we know that 25 goes into 104 times, so it must go into 208 times. And so we are paying 18 cents per ounce for the Simply Orange. So in this case, the better buy would be the Simply Orange. This slide just recaps what we have discussed regarding calculating unit rates. A unit rate is a rate in which the second quantity is 1 unit. So we refer often to the unit rate as either a unit price or unit cost. And the best way to remember this is unit comes from uno, which means 1. So we want to find out how much we're paying for each one. So in this example, we want to find what the unit rate is for these yoga classes. Gerald pays $90 for 6 yoga classes. So our first step would be to write the rate of $90 to 6 classes. So we're writing a rate with the given information. And then our second step would be, what is the cost per class? So after we have our $90 to 6 classes, which was given, the question is asking us, what is the cost per class? That means we want to know how much we're paying for each class, for one class. Well, in order to get from 6 to 1, we're getting smaller, so that means we're going to divide. And 6 divided by 6 will get us 1. What we do to the classes, we must do to the dollar amount. So 90 divided by 6. And let's go over to the side and let's do that. 90 divided by 6 goes into 9 one time. Take 6 from 9, we get 3. Bring down the 0, and that's going to be 5 whole times. We take 30 from 30, and that'll get us $15. So in order to answer this question, our step 1 was to write the rate for the information given. And our next step was to find out how much we're paying for each class. So we found the unit rate, which was $15 per one class. Similarly, if we have the cost of 2 cartons of milk for $5.50, our first step would be to go ahead and write the information given as a rate, so $5.50 to 2 cartons. And they're asking us for the unit price, which means how much are we going to pay for each one carton. So let's go ahead and rewrite the information given, $5.50 to 2 cartons. We want to know the unit price. That means we want to know how much we're paying for one carton. And so we're going from 2 to 1, so we know we're getting smaller. We're going to divide by 2 because 2 divided by 2 will get me 1. What I do to the cartons, I have to do to the dollar amount. And so let's go off to the side and do $5.50 divided by 2. We're going to bring up the decimal point. 2 goes into 5 2 times. We take 4 from 5. We get 1. Bring down the 5. 2 goes into 15 7 times. 7 times 2 is 14. We take that from the 15. We're left with 1. And our final number to bring down is 0. So 2 goes into 10 5 whole times. And our answer then would be $2.75 to 1 carton of milk. This was another neat question that we did in class, and we talked about comparing a hot air balloon that rises 9 meters every 3 seconds to a blimp that rises 7 meters every 2 seconds. We were asked to complete the ratio table for each aircraft and then asked to determine which rises faster. What I thought was really cool about this is that you guys all came up with really different ways of explaining this one, and I thought that was really neat. So the first thing that we want to do is let's focus on the hot air balloon and let's complete the table. So the hot air balloon is rising 9 meters every 3 seconds. So Every 3 seconds, this hot air balloon is rising 9 meters. So if we go another 3 seconds, that would be 6, and another 9 meters would be 18. Again, completing the table, if we're going another 3 seconds, that would be 9 seconds, and another 9 meters would be 27. Lastly, we have another 3 seconds, which would be 12, and another 9 meters, which would be 36. Let's do the same thing with the blimp and complete that table. The blimp, on the other hand, is going 7 meters every 2 seconds. So every 2 seconds, the blimp is going 7 meters. So another 2 seconds would be 4, another 7 meters would be 14. Another 2 seconds would be 6, another 7 meters would be 21, another 2 seconds would be 8, and lastly another 7 meters would be 28. So a lot of you, what you guys did is you took information from both the balloon, the hot air balloon, and the blimp, and you said, let's see, I think you guys matched it up with, I think what you guys did is you went over to the blimp and you added another 2 seconds, which was 10, to another 7 meters, which was going to be 35. And you went one more time, you went to 12 seconds, and another 7 was going to be 42. And the reason that you guys did that is you understood that you can use this table in order to match up, and by completing the table you can also compare rates. So in addition to using that multiplicative relationship, you guys also did a great job of using the table to help you determine which aircraft rose faster. So what you did is you guys looked at the 12 seconds that it took the hot air balloon and the 12 seconds that it took the blimp, and you said, well, at 12 seconds the hot air balloon was at 36 meters, whereas in 12 seconds, the blimp was at 42 meters. So the one that rose faster was the blimp. Others of you did not need to go further because you noticed that at 6 seconds, the hot air balloon was at 18 meters, whereas the blimp at 6 seconds was at 21 meters. So clearly the one that rose faster was the blimp. Another real-world problem that we worked on in class was using rates to make predictions. In this scenario, we have Janet, and Janet is driving from Clarkson to Humboldt, and it's taking her 2 hours. This is the information given, and she went a total of 112 miles in 2 hours. The question is then asking if she maintains the same driving rate. Can she drive more than 600 miles if she's driving for 10 hours? So some of you use the multiplicative relationship and you said, I need to get from 2 hours to 10 hours. And so you understood that to get from 2 to 10, we're getting bigger, so you're going to have to multiply by 5. What you do to the hours, you do to the miles. So 112 times 5, 5 times 1 is 5 plus 1 is 6, and 5 times 1 is 5. So this would give us a total of 560 miles. In order to answer this question, the answer would be no, she is not going to drive more than 600 miles because at this same rate, she's going to drive 560 miles in 10 hours. Others of you, however, decided to complete a table in order to solve this question. And so you notice that information given was that Janet drove 112 miles to 2 hours. Well, in another 2 hours, that would be another 112 miles, which would make Janet's drive at 224 miles to 4 hours. Again, adding another 2 hours would be 336 miles to 6 hours. You would add another 112 miles in another 2 hours, and she's at 448 miles to 8 hours. So what some of you did is you added the 112 to the 448, which gave us the 560 miles in 10 hours. Whether you completed the table or you used the multiplicative relationship, you still can come up with your answer and you would be able to justify it. This concludes our review on Module 6, Ratios and Rates. Any questions? Please feel free to ask.